Hello students. So in the previous classes we have learned the combination of resistors, that too in series and parallel. I hope all of you understood the series combination and the parallel combination very well, and also the practical way how we can use the series or the parallel combination. That also you have realized the benefits of the parallel combination through the activity. I hope all of you have understood and you have prepared your notes also. So today let us study the electrical energy. So all of you might have experienced the conversion of electrical energy into heat energy. So any device, if you allow electric current to pass through it, a common bulb, if you touch, you feel the hotness. So electrical energy can very well convert to heat and light. So when the current passes through a device, how much electrical energy will be produced, or how much energy is consumed by that device, that we can learn today. So let us first study about the electrical energy consumed by a device, and that is developed by a scientist named Joule, and that law is called as Joule's heating effect. So according to Joule's heating effect, the heat energy produced, H, it is marked with the letter H. So energy, you know that energy can be always related with the work done. I hope you remember the equation for the work done in bringing or moving a charge from one point to another point. The first lesson, first part of this electricity, you learned an equation. W by Q is equal to V. So from there we can write the work done as V into Q. So we can take always the energy and work done, they are mutually, we can convert work done to energy. We can say that they can equate. The work done can be always equated to energy consumed or energy used. Therefore, the work done in making a charge to move from one point to another point, thereby making the electric current to flow through that device, can be equated as the heat energy. So we can take that equation as V into Q. This is nothing but Joule's heating effect. So we learned that this Q as I into T. Therefore, H is equal to VIT. This law is called as Joule's heating effect. Now we can substitute for this V and I in different forms from the Ohm's law. Ohm's law states that if R is the resistance of the device through which this current is passing through, then we can write it as I into R. So if we substitute for V as IR, this equation we can write it as IR into IT. So that this is equal to I square RT. So this is one equation, this is the second equation, and again we can substitute for I from the Ohm's law as I is equal to V by R. Therefore, this equation can be rearranged as V into, instead of I, we can write it as V by R into T. Therefore, this equation will become V square by R into T. Equation number 3. Now you see we have got three different equations for the heat energy dissipated or heat energy consumed by a device as H is equal to VIT, H is equal to I square RT, H is equal to V square by R into T. Now look at this equation and this equation. If we explain Joule's law of heating effect as yellow if you are telling, this equation is giving us an idea that heat energy produced or energy consumed is directly proportional to the resistance. Yes, is it clear for you? Because R is coming in the numerator, we can say that H is having a direct dependence on the resistance. But when we take this equation is telling that H is inversely depending on resistance. So, same quantity to the left side, that is energy consumed, but the right hand side we are getting two different interpretations. What is this one telling? This equation telling heat energy produced is directly depending on resistance. This is telling inversely depending. So, same quantity in two ways depending on a similar quantity, means this is a direct dependence on resistance, this is an indirect dependent on resistance. This is a contradicting statement. Is it so? These two equations are contradicting each other. But why it is so? That we have to find certain reasons for that. So why this contradiction is coming here? So can anybody answer? So this equation is different, this equation is also different. Only the t term is same, time is same. So when it is directly depending on the resistance, energy consumed is depending on current. Means when current is constant, we can take this equation as I square RT. But when the potential difference is same through different devices, then we can say that when V is maintained constant, it is inversely depending on resistance. So when I is constant, direct dependence of resistance. When V is maintained constant, it is inversely depending on resistance. So this is not contradicting. In two different situations, we have to use this equation. So if the resistance is not known, we can take the equation H is equal to VIT. So according to Joule's heating effect or Joule's law of heating effect, heat energy produced is equal to VIT or I square RT, or it is equal to V square by R into T. So what is the unit for measuring energy? Again named after the scientist, heat energy is measured in joules and it is writing with the capital letter J. When this is the energy, we can calculate electric power. We can find the electric power. So how can we find the electric power? So when we find electric power for a device, so we can relate always power with the energy. We can relate the power with the energy. So when we take the heat energy equation as VIT, the power, electric power, denoted by the letter capital P. We can write it as P is equal to, so what is the basic equation for power? Power is equal to, last year you have studied, work done by time or energy by time. So here we have derived already an equation for energy. Therefore we can say that power is equal to energy by time. A rate of consuming energy. Rate of energy is used. So that can be denoted as the power. And since E is equal to VIT here, we can take it as VIT by T. Therefore power is equal to VI. Again the second equation, I square R, we have to divide with the T. The third equation, P is equal to V square by R. So this is the first equation for power, second equation for power, and the third equation for power. So electrical energy is one T term will come there, time. If you remove time, that will become the equation for the power consumed. So what is the unit for power? Normally power is measured in a unit watt, writing W, and higher units like kilowatt also will be used in some instances, and Normally the standard unit for power is watt and denoted with the W. And these equations we have to use in calculating the electrical energy consumed by devices, heat energy dissipated. Also we have to use this equation for the rate of consuming the energy or the calculation of the power. So the standard units for energy is Joule, standard unit for power is watt. But there is another unit for energy which is called as the commercial unit. Commercial unit of energy. So what is the meaning of commercial unit? Because we are all using electrical energy for our day-to-day life. We are using electrical energy. Actually we are buying electrical energy and we are paying for that. So the bills what we are calculating, there we are commercially we are calculating. So the commercial purpose when we use the electrical energy, so there is a single unit for measuring the energy in higher order. So joules if you are calculating, every time the bill will be having bigger and bigger numbers. So to reduce the digits in the bill, we can have a commercial unit. It is a higher unit. So normally in everywhere energy will be measured in joules, but only for the buying and selling of the electrical energy we will use this commercial unit of energy. So the commercial unit of energy is kilowatt hour. So how we are getting this kilowatt hour? There we have seen that power into time. Power into time will be again equal to energy. Yes, power into time is energy. Therefore, if the power is in kilowatt, the time is in hour, we are getting a new unit for energy which is called as kilowatt hour. So kilowatt is the higher unit for the power and hour is the higher unit for the time. So energy when you take it as a product of power and the time, the higher unit of power kilowatt if you are using, higher unit of time when we are using, a new unit called as commercial unit of electrical energy we are deriving, and that is called as kilowatt hour. And 1 kilowatt hour is equal to, so because kilowatt we know that it is 1000 watt. 1000 watt into how much? 1 hour. 1 hour is 3600 seconds. So 1 kilowatt is 1000 watt. 1000 watt into 3600 seconds. So that this can be written as 36 into 10 to the power of 5 watt seconds. So this watt second will become just joules because standard unit for power is watt, standard unit for time is second. So product power into time is energy. If the power is in watt, time if it is in second, then energy will be in joules. Therefore the watt second is in joules. So this is equal to 36 into 10 to the power of 5 joules. So we can convert 1 kilowatt hour to joules. So how much it is? What is the relationship? 1 kilowatt hour is equal to 36 into 10 to the power of 5 joules. So this kilowatt hour is simply, it is called as unit. You might have heard in your house when the electricity bill is coming, or people may be talking, how many units of energy consumed, electrical energy bill when it is coming, how many units this month we have consumed. So depending on units we have to pay the bill. So the unit means it is nothing but kilowatt hour, and 1 kilowatt hour is equal to 36 into 10 to the power of 5 joules. So this is a commercial unit of energy. So if we know the power of a device and how many hours we are using that particular device, we can calculate how many units of energy is consumed. For example, in your home, if you have a 40 watt bulb, you are lighting it for 8 hours. You are lighting the 40 watt bulb for 8 hours. 40 watt bulb for 8 hours. So this watt you have to convert it into kilowatt by dividing it with 1000. So this will become 40 by 1000 kilowatt into 8 hours. This much unit of energy that bulb will consume for 8 hours. So 0.04 into 8. That much of electrical energy in one day that bulb will consume. So you can calculate very easily. If you know the power of the devices in your home, you can very easily calculate how many units of energy each device will consume. So depending on that we can calculate the electricity bill, provided you must know what is the cost of 1 unit. So if you know that value, you can calculate the electricity bill of your home. So from this what we can learn? Heat energy can be produced when electrical energy is passing through devices. So we can have certain devices. You might have seen many devices like electric iron box, electric coils. Wherever coils are used, electric coils, what is the principle? Electrical energy is converting into heat energy, and electric iron box and electric ovens. So all these things we can say that electrical energy is converting into heat energy. So there we will be using coils which is having very high melting point. The properties of the coils which is to be used for making this kind of heat energy, the dissipating or heat energy producing devices, the coil should have high melting point. So and also the resistance, it should have very high resistivity. So high melting point and high resistivity materials we can use for making heating coils. Usually pure metals cannot be used, alloys will be used, and usual material which is used for making heating coils made out of nichrome. It is an alloy of nickel chromium, and that we can use it for making the heating coils. So heating coils are made with the materials of high melting point as well as a high resistivity, and these heating coils energy produced can be practically useful for devices such as electric coils, electric iron box and electric ovens. And you may ask, the old electric bulb, incandescent bulb, there also the principle is the conversion of electric current to heat energy. So how can we make the use of that? What is the principle of electric bulb? In the case of electric bulb, we can say that the bulb is having a small hair-like filament. So hair-like filament, and all of you might have heard about the element tungsten. So tungsten has a special property, it can be made very thin. That property of the tungsten is made use there, and also it has very high melting point. So due to the high melting point and its basic nature that it can be made very thin, hair-like, and the heat energy produced is again converting into light. So electrical energy to heat energy and heat energy to light energy. So what is the basic property of tungsten? Tungsten has very high melting point and it can be made into very thin wire or hair-like structures, so that we can be used it as a filament. When electric current is passing through that tungsten filament, what will happen? It will get heated up and finally that heat energy will be converting into light. So that is the property of tungsten. And the bulb, you know that bulb will be the filament of the bulb, incandescent bulb. There is a glass case. In that a rare gas will be filled, nitrogen or argon, it will be filled. So why it is filled? Because when this filament, if it is come into contact with the air, what will happen? It will catch fire. So that burning or that can be avoided if it is filled with a rare gas. So that lesser density gas, if you are filling, always that will be trying to come out, air will trying to occupy. So what will happen? The filament will not get direct contact with the air, and hence we can avoid the catching of the fire. It will not get oxidized when it will not get contact with the air, and hence it will not get oxidized. Also, this nichrome alloy is having a property that it will not get oxidized. It will not get oxidized. Even though it is exposed to air, the alloys like nichrome will not get oxidized. That is why heating coils are made use of alloys such as nichrome. And another element you might have heard, electric fuse. Fuse wires are made with lead, tin, etc. So what may be the property of that fuse wire? Why we are using fuse, electric fuse? Electric fuse is using for breaking the circuit as a circuit breaker. Whenever we use a device more than the required amount, if the current is entering or current is coming through into the circuit due to some kind of fault that you will study in the next chapter, like a short circuit or overloading. In that case, if an excess current is coming, this fuse will melt and break the circuit so that our appliances will be safe. So what kind of a material we have to use to construct a fuse or making a fuse? So fuse can be made with the materials like a lead or tin. The speciality is it has low melting point and also it should have good conductivity. So lead or tin with a less increase of the temperature, it can be melted. It has low melting point, therefore the fuse wires are made out of lead or tin. Also it should be made very thin according to the need of our circuit. If we can make 5 ampere fuse, 2 ampere fuse, 3 ampere fuse, like that. If we want to allow 5 ampere current to pass through the circuit or the device, that way we can design the fuse depending on the thickness of the wire. So we can have the different values for the fuse wires, or the fuses can be of different kinds. So different capacity we can make so that it can act as a protection for our devices or the circuit. So that is the principle of electric fuse. So the electrical energy converting into heat energy, we can have devices such as heating devices like electric coils, electric iron, electric ovens, etc. The speciality is it should have high resistivity, high melting point, and also materials such as alloys we can select because it will not get oxidized. And electric bulb is again an application for the heat energy developing inside the bulb through the filament. So the nature of the material which is to be selected to make a filament is tungsten. The speciality of the tungsten is it has high melting point and also it has the property that it can be made hair-like. It can be thin hair-like structures. So it can be made very thin so that area of cross section when it is less, we can say that the heat energy whatever it is producing can be converted as light when it is very thin. So the filament of the bulb is made with the tungsten filament. Electric fuses are made with the lead or tin because they have low melting point. So when this side coils, that should withstand heat, but in the case of fuse it should be a circuit breaker. Therefore we have to use a low melting point element for making electric fuse. So I hope you understood the heating effect. So all these equations you have to study properly.